Assalamu alaikum warahmatullahi wabarakatuh. My name is Abdullah Yunus, and today we'll be discussing our research topic distributed parallel particle swarm optimization for multi-objective and many-objective large-scale optimization. My name is Abdullah Yunus, F2017266205, and my team members are Muhammad Zaid Ajmal, Muhammad Usman Munir, and Rahim Khan. Let's start on our topic. First of all, we'll talk about the description of the problem. Due to the growing trend of the big data era, difficult optimization hurdles with multiple targets and huge quantity of decision variables are popping up. As you know, there's a lot of complex problems at hand these days, and in order to excel at those, we have to figure out a way to process all of that information, to process all of those variables, and provide the people with a good and feasible technique in order to tackle the huge data hurdles. MOPs with larger quantity of variables and objectives are coming up in the modern fields. Traditional methods can only handle lower than 4 objectives and small number of variables only. There's a lot of advancement and work needed to be done in the related fields. PSO is not applicable on MAOP. MAOP is a many objective optimization, and PSO is particle swarm optimization. The execution time of other algorithms will be huge, and the computing it would help us execute these algorithms. The DNP computing, the DNP as in distributed and parallel computing. It will be much more efficient with respect to time and speed if we use our topics and our understanding of distributed and parallel computing, and we integrate it into this particle swarm optimization work that's been done in this field. There's been a lot of prior work that's been done in this field since a lot of time. There's a lot of conventional and traditional methods, but none of them have been proven to be really helpful in this scenario. But anyways, we'll discuss the work that has been done so that we can get a brief idea of what we're about to do. We use different algorithms with different efficiencies. Our main goal was to maximize the number of variables computed. Kennedy and Eberhard proposed the PSO approach in 1994, and their proposal, it wasn't very optimal or efficient at all, but it was revolutionary, and it gave us a lot of possibilities and exploration into this field. And then multi-objective optimization (MOPs) was done on large scale. Earliest work in this scenario was done by Coelho and Lechuga. Prior work in this field, but it did not successfully tackle a large number of variables. Then Li and Yao used the CC framework, and using this framework, they were able to compute up to 2,000 variables. And normally, we couldn't even compute 4 variables at once using the traditional methods. So this was a huge revolutionary advancement in this aspect. Cooperative coevolutionary generalized different evolutional tree. This is a technique method CCGDE3. This is a lot of different techniques integrated into one, and we use this to compute MOPs, and we were able to compute up to 5,000 variables. This approach is highly used for MOPs these days. The CCGDE3 is the one that we're using the most these days because of its high advance and efficient computation with respect to the variables. The prior work in this field has brought us really far ahead, but there's still a lot of advancement and there's still a lot of things that can be done. As you can see in this little diagram, we're differentiating between many objective and multi-objective SOPs, and we're actually looking at the theory-wise advancement and the actual practical advancement in this field.
My name is Zaid Ajmal. As Abdullah described the description of the problem and the pioneer work, now I am going to focus on two questions, which are what is the problem of the what is the solution of the problem, and what was the methodology proposed. First, I will describe what was exactly the main problem is. As we know that big data technology is advancing day by day, and this advancement is causing many complex problems. These complex problems are occurring again and again in engineering and scientific fields, which can be solved using optimization. So because of that, we are facing complex optimization problems. Complex optimization problems are those problems whose objective numbers are greater than 4, or they have very magnitude of object variables can be up to 10 power 3, and they have large number of variables. Now I will describe what was exactly the problem solution is. PSO, Particle Swarm Optimization. Particle Swarm Optimization, short form is PSO. PSO is a heuristic global optimization method. It is the most commonly used technology to provide optimal solution set. There are many other algorithms like GE, ACO, ABC, BA, but PSO is the main and old technology method we use to provide solutions. PSO was introduced by Kennedy and Eberhard back in 1995, and it was inspired on the choreography of a bird frog. That is where the idea came from. As I described, PSO focuses on many optimization problems, that is MOPs, but we are facing problems with many optimization problems, that is MAOP. So there was urgent need to design novel PSO algorithms to handle large scale problems. In this paper, they focuses PSO with other technologies, and after that they propose three methodologies, which are multiple objective large scale optimization, many objective optimization, and distributed parallelism. First, I will describe what is multiple. I will start from first methodology, that is multiple objective large scale optimization. As I told you before, large-scale problems are those whose magnitudes are whose objective variables magnitude can be up to 10 power 3, and from as the name told here, large scale means objective variables that can be up to 10 power 3 magnitude. Poilo and Lechuka give the idea of multi-objective PSO, and MOPSO is its short form. As we told, large scale problems are those whose powers are 10 power 3. It cannot handle that problem. So for that, we introduce cooperative coevolution, which is CC framework. CC short form is cooperative evolution was introduced to deal with the large scale problems. CC, I will tell you what is done. CC decomposes the large scale problem into many small problems using divide and conquer technology method. As we know, divide and conquer technology, and is and my research case study, I have attached MOPSO algorithm of 8 lines to while, and they have a function particle a pop. They initialize a pop of the particles, and then they deal with one by one using divide and conquer technology. CC framework decomposes the large scale problem into small problems which can be. Now second thing is many objective. Second methodology is many objective optimization. In MAOPs, dimensionality of objective space is high, and we use this visualization approaches to deal with that. As we know, visualization approaches are different, that uses for many objective problems and many many objective problems, multiple objective problems. So there was a need of visualization method that can solve many objective optimization. He and Yen put forward a visualization method for MO. They propose a method and a visualization method that can deal with the space problem. Individuals from a high dimension map objective space were to be a polar coordinate plot. This was solve the space problem. Now, third thing, distributed parallelism. As we know, number of whatever I told you before that can go up to power, which are very more. See, if we use serial algorithm and only one a personal computer, it cannot solve the problem. The other consumption of time of other algorithms is much more greater because of these large number of objectives in many objective problems. So we use distributed parallelism. Distributed parallelism can accelerate the speed for problem solving of a large problem. We use a different distributed parallelism technique that can accelerate the to solve the complex problem. So because of which the consumption of time will be shorter and we will having result fast, which is one of the problems we are having if we use GSO with MOP. Any objective problems, there was a problem of slow results and complex because of complex problems. So we use different distributed parallelism techniques, and because of that, it can accelerate the problem.
Assalamu alaikum. My name is Muhammad Usman Munir and my ID is F207266232. I'm here to talk about the proposed method. We have two different categories for the one is multi-objective and second is many objective to solve this scenario. First, we talk about the multi-objective. In this method, we combine two above methods, that multi-objective, large-scale optimization, and distributive parallelism. We will combine these two methods, and we will use the divide and conquer approach. In this approach, we divide the algorithm in different parts to get our best results, and we will use it in our this scenario. So we start analyzing the large variable numbers. We start dividing into the group variables. Then we combine those groups of all better for our better optimization to get a better framework. After this working, we will get a multi-objective algorithm so that we will work under a better framework. After this, we have multi-objective, large-scale distributing parallelism. Now we have to talk about it. For multi-objective, the dimensionality of the object space is high and the population section pressure is low. Therefore, this method we're using from the past time we will not applicable for this. So we can have a better solution for it. We will design a multi-objective large-scale distributing. According to this, we have seven kind of main many objective characteristics. These characteristics will help us to make a new and a better algorithm so that we can solve the large number variable numbers. These seven classes, we get more efficient approaches by solving these large numbers. This novel many-objective large-scale algorithm can also absorb the advantages of traditional mathematical theories and methods we are using from the past. Uh, we can make some better algorithm for this, which can also approach the PSO algorithms. So this is a very benefit for us. Thank you.
Assalamualaikum. My name is Rahim Khan and I am discussing about the result and discussion. So with the quick advancement of dispersed parallel computing, advance and the coming time of huge information on us, complicated issue can be changed into multi-objective and many-objective large-scale optimization. Hence the implementation on this method parallel PSO for multi-objective and many-objective large-scale optimization has imperatively investigate importance. In this association, two studies related investigate on PSO calculation, multi-objective large-scale optimization, many-objective optimization, and dispersed parallelism. At the point, the multi-objective large-scale conveyed parallel PSO and many-objective large-scale dispersed parallel PSO technique are proposed and discussed and the other imminent investigate pattern are to displayed and examined. The distinction between the MOPs and MAOPs is that the number of goals is diverse. In any case, the determination of optimization methodologies may be diverse. The investigation on planning multi-objective large-scale conveyed parallel PSO calculation to begin with. At that point, coordination, novel variable decay and optimization technique able to ponder the many objective large-scale dispersed parallel PSO calculation. For handling multi-objective and many objective large-scale optimization, when the objective number is huge and the number of factors is tremendous, the optimization prepare will be greatly time consuming. Based on the conveyed parallel procedures, the optimization range can be apportioned to expensive sums of computation units, which can variably make strides the running productivity and of the investigator's pattern. The leftover portion of our paper takes after multi-objective large-scale optimization describe related queries about PSO calculations for multi-objective large-scale optimization. Many objective optimization followed in dispersed parallelism in the main focus of distributed parallel PSO calculation. In many part, so what I understand in this whole presentation and project is that in my part of the write-up I covered the 2 points which are result and discussion and any dataset of stimulation and analysis. I think the dataset of for the stimulation and analysis are not available in this project, so I skip this part and focus on result and discussion. And what I understand from this project is that considering how to utilize the over calculation to illuminate real life optimization issue is of imperative importance. Within the general world, optimization issue may exist in numerous areas, a certain number of which are exponentially development calculations, not at all like a few complex calculations. Due to its basic structure, PSO can be effectively executed and is commonly utilized to handle complicated optimization issues, such as the 2D plane sending issue of remote sensor system, etc. All of this is what I have learned from my part of handling this research article. Thank you very much. Assalamu alaikum.